Hello guys, welcome back to my channel Pivotal Inquisition. So today we are going to have a look on important question of physics. But before I start, I want to tell you that if you are new to my channel, then do subscribe it because you are going to find all the important question of PCM on my channel. So now let's have a look on the question. The question says, two monochrmatic light are incident normally on the face AB of an isosceles triangle ABC. The reflective index of a glass prism for ray 1 and ray 2 are respectively 1.35 and 1.45. Trace the path of these rays after entering the prism. So what we have to emphasize is that we need to find the path of these rays after they enter the prism. So the path of first ray is being shown by an arrow this, and the part of the second ray is being shown by the arrow this. The black part has already been given in the question. The blue part we have done at solution, and then we have tried to make its path. So if we try to divide this question into two cases, case 1 and case 2, where case 2 stands for the ray 1 and case 1 stands for the ray 1, and what we need to know in this question that if the ray has been traveling through a prism, then surely or maybe it may be undergo TIR or may not be, but the conditions required for TIR that I should be always been given the C, where I stands for the angle of incidence and C stands for the critical angle. The angle of incidence should always be given in the critical angle, and the second condition that they should always be driven from a denser medium to a radium. Some people might get confused that it gets transfer from a rarer to a denser medium in this case, because here if we try to extend this ray when it enters in the prism, now it is being at point Q and at point P it is going to deflect or it is going to reflect. So at this point at P and Q, here it is being in denser medium and now it is coming towards the air, so it is a rarer medium. So when it is coming from rarer medium to denser medium, then it satisfies this condition. If this condition is already been satisfied, we have to look for this condition. So if we want to look for this condition, we are dividing the case into 1, again case into 2. Mu is equal to 1 by sin C. We already know by the definition of TIR or by the conditions of TIR. We get the value of U as 1.35 and 1 by sin C is a direct one. For TIR, we know I should be greater than C and sin I is equal to sin 45, which has already been given. If we try to extend and put a normal over here, then we get this angle as 45 degree. So we sin 45 is equal to 1 by root 2 and root 2 is 1.41 and sin C is equal to 1 by 1.35, and we know that we have the value of sin C and we have the value of sin I. So in normally 1.41 is greater than 1.35, but in the case of fraction where the greater value is in denominator, we have to do this in opposite way, like sin C here is been greater than sin I, C is greater than I, but this condition is not being satisfied by TIR. So TIR will not fall in this. So now let's have a look on the second case. So if we try to have a look on the second case of ray 2, here we are having the value of sin as 1.45 and we are having the value of sin I, it is 1 by root 2 as it was already in earlier cases, but for ray 2. Remember, not for ray 1 but for ray 2. Now TIR in this case will take place because sin I is greater than R and I will be sin I is greater than sin C, sin I is greater than sin C, so I is greater than C, and hence TIR will take place in this case, not in that case. So with this we have completed our question. If you want to note it down, do post the video and have a look. Thank you guys. We'll meet you in next video.